Hello, everyone. Welcome to the Data Umbrella webinar for March. Today's agenda is I'm going to do a quick introduction, and then Ryan will be doing his talk, and we'll have Q&A at the end, but also feel free to post any questions either in the chat or in the Q&A tab, and we'll make sure that they get answered at a good point where we can either interrupt Ryan or answer them at the end. This webinar is being recorded, and it's usually available about a day after the event. Sometimes it takes a few extra days, but it is on the Data Umbrella YouTube, and I'm going to put a link to that in the chat as well. A little bit about Data Umbrella is an inclusive community for underrepresented persons in data science, and we are volunteer run. A quick background about me. I'm a statistician by training. I have a master's in statistics and an MBA from NYU. I am on Twitter, LinkedIn, and GitHub as @Reshama, so feel free to follow me on any of those platforms. We do have a code of conduct. We want to make sure that this community is welcoming, friendly, inclusive for all. So please keep that in mind, and that applies to anything that is posted in the chat as well. Please be mindful of what is posted in the chat. We're happy to answer questions and have chat. The best ways to support our community is first and foremost is to follow our code of conduct and contribute to making it a welcoming and collaborative space for all of us. We have a Discord, and the link to Discord is on our website. There you can ask and answer any general questions for the community. And we do have transcripts of all of our initiative is to have transcripts for all of our webinars, and that is on our GitHub. Another way that you can support us is donate to our Data Umbrella Collective. We are on all, you can pick whatever platform you sort of have a preference for, but we're on all social media platforms as Data Umbrella. The best place to find out about upcoming events is at our Meetup, group. We have a really comprehensive video library of webinars that we've done for the past year. And so one of the playlists is contributing to open source. And so there's webinars on computing to NumPy, scikit-learn, pandas, core Python, so check it out. We also have a few webinars that we've done on career advice in data science and tech specifically. So if you are in, if you're looking for career advice, these are great videos to check out. And this is just sort of a sampling of some of the recent events that we've had. There's Plotly and Streamlit. So there's a lot of good resources. We also have a job board. So if you're looking for work, feel free to check it out. And if you work for a company and you have job postings, feel free to post them. Our job board is now free. So feel free to share any job postings there as well. Our website has a lot of resources on open source, using inclusive language, allyship, burnout, AI ethics. There's a lot of information there. So depending on what you're looking for, please check it out there as well. These are other ways to connect with us. We have a LinkedIn page where I share job postings as well. And you can subscribe to our YouTube. I'll share the link in the chat. Our next event is going to be the wonderful world. Sorry for the noise, it's New York. Wonderful World of Data Quality in Python by Sam Bell, who is a returning speaker. And that is in 2 weeks on March 23rd during lunchtime, New York time. So I want to introduce today's speaker. His name is Ryan Kruse. He just completed his master's in data science at Minnesota State University, Mankato. Congratulations, Ryan. That's a great accomplishment. Ryan currently works as a data science consultant and community manager for SafeGraph, and he enjoys using data in creative ways to solve problems. And so I just want to add a little bit of a background on Ryan's presentation, which has to do with the recent data related to the recent elections. in the United States, we had our general election in November. There were the 2 Senate seats in Georgia. Georgia's a state in Southeast United States, for those who are unfamiliar, and each state has 2 senators. And so this was a really close election. And there were 2 Senate seats that had a race-off election, a tie. Let's see, the results were very close. They were so close that they had to have another election to run us, and they called it a special election. And this was a really, really critical election because the Senate is broken down by party 50-48, and so these 2 seats are really critical in determining what these votes are going to be in the U.S. Congress. And with that, I am going to go on mute and hand the screen over to Ryan.
Thank you, Reshama, for that introduction. I'll go ahead and share my screen here. Okay, are my slides visible?
Yes, we can see the slides now.
Okay, excellent. So as Reshama said, my name is Ryan Kruse, he, him, and I will be presenting on my political census using Placekey project. It's been a fun project for me to work on, so I'm excited to share it with you today. First, a quick overview of what the presentation is going to be like. We'll start with the objectives, and we'll go through an introduction, the background materials that you might need to know. We'll cover any assumptions that we need, and then we'll go through the methods. Then we'll move over to Google Colab and go through the live code demo. You're welcome to follow along with that. Otherwise, we'll have the notebook available to you afterwards. And then we'll talk about any limitations and considerations, and finally finish with the conclusion. The objectives of today's presentation are to demonstrate the following 3 things: the power of geospatial data, the value of Placekey for joining geospatial data, and a foundation for a cool application, which is estimating political affiliation. The introduction will have 3 parts. First, what is a political census and why is it valuable to build one? Second, what data sets do we need? And third, how can we join these data sets effectively? So first, what is a political affiliation census? I apologize for all the words on the slide, but I wanted to have the information there just in case the sound cuts out for anybody. In our context, a political census is data on political affiliation at the census block group level. Census block group, CBG, is the smallest level for which the U.S. Census Bureau publishes sample data, and it contains 600 to 3,000 people. So the U.S. Census Bureau publishes demographics data at the level of a census block group. Political affiliation is a useful variable in research, and it's been linked to things like religious extremity, vaccine refusal, stance on corporal punishment, and much, much more. Political affiliation data is currently only available at the county or district level typically, which overlooks really important variation. This means that any meaningful research using political affiliation has limitations or must rely on survey data, which has its own limitations. So let's see what a political affiliation census might look like. On the left here, we have this image from the New York Times, which shows the state of Georgia broken down by county and the political affiliation of each county, according to the 2020 general election in November. So we see here we have Cobb County and Forsyth County. Cobb County is slightly Democrat-leaning, which is blue, but if we break it down by census block group, which is what's going on over here, we can see that there's actually quite a bit of variation within that county, where these census block groups up here are actually tending more Republican. And these ones, as you get closer to the city of Atlanta, tend to be more Democratic. If you look at Forsyth County at the top, it's actually pretty consistent throughout the county that it is slightly Republican leaning. Okay, so what data sets do we need to build that political affiliation? First, we need the 2020 general election results by polling location. The results and polling location are often in separate data sets, so we usually have to join them together. And also we need SafeGraph patterns foot traffic. It gives the home census block group of visitors to POIs, such as businesses, polling locations, churches, and any POIs that you can think of. And it also gives info like dwell time and visitor distance traveled, which could be valuable if you're trying to assess things like accessibility to voting. There are some limitations to the data. First, it's foot traffic only, which means that we're missing out on all the mail-in ballots. Second, there might be missing CBGs. And third, there are sometimes missing POIs that just don't show up in the SafeGraph patterns. So here's an example of a SafeGraph data point for a POI. Specifically, we're looking at Walmart in Wisconsin Dells, Wisconsin, for the month of June 2020. We saw 4,188 unique visitors in SafeGraph's data to this point of interest. And you can see a map of where those visitors came from. So the dark red here in this map represents that a lot of visitors came from this census block group to Walmart. And the lighter red here shows that just a couple of visitors came from this census block group to Walmart. And of course, if there's no colors, then no visitors came to Walmart from those census block groups. So if you can imagine that we replace Walmart now with a point of interest that is a polling location, and we can see that maybe most of the visitors came from this census block group, and some of them came from this one, and none came from up here. And that's kind of what we're using to decide, okay, what are the political affiliations of each of these census block groups? And one extra thing to keep in mind is that a voter from each of these census block groups might have voted at this location, but maybe another voter from this census block group voted at another location, and another voted over here. So we need to find a way to put all these vote totals together and estimate accurately how the census block group affiliates politically. And third, how are we going to join the data? Joining POI and address data is hard, and Placekey makes it easy. The problem is that address data are rarely standardized. For example, AV might be represented with or without a period, or it could be spelled out as avenue, and they all mean the same thing. Additionally, Northwest could be the entire word, or it could be the initials NW. Placekey solves this problem as a free, open, unique standard identifier. Let's talk about what the breakdown of Placekey is here. There's two components to Placekey, a what portion and a where portion. The where portion, these 9 characters right here, represent a hexagon somewhere on the world with a diameter of about 47 meters. So it's a pretty small area when you think about the entire world. Given the where portion of the Placekey, we have these what portions. The first 3 characters represent the address encoding. So given an address, maybe 123 Main Street, in this hexagon, we can figure out what the address encoding is here. And the second 3 characters correspond to a POI specific encoding. So let's say at 123 Main Street, we had a McDonald's until the year 2015. And then in 2016, that McDonald's became a Taco Bell. The Taco Bell and the McDonald's share the same address, but they're going to have unique POI components of their Placekey. In this way, Placekey allows us to overcome the changes in addresses across time. So here's a look at our 3 data sets and how we're going to join them. At the top, we have the election results by precinct. So we have a precinct column along with the registered voters, election day Trump voters, advanced Trump, mail, total, election day Biden, and so forth. We're mostly interested in the election day vote totals for each candidate. Next, we have the precinct locations that also come with a precinct column, along with these address columns. We'll use the address columns to append Placekeys to the precinct locations, and then we'll join with the election results on the precinct column. Once we have those 2 data sets joined, we can use Placekey to join with the SafeGraph weekly patterns. SafeGraph weekly patterns represent the foot traffic to a POI during a given week, and it comes with Placekey automatically. The column that we're most interested in SafeGraph's weekly patterns is this visitor home CBGs column. It's a JSON value, kind of like a Python dictionary, where the key is a census block group, and the value is the number of unique visitors from that census block group to the given point of interest. So we want to combine the data sets so that we have the visitor home CBGs linked up with the election day vote totals by candidate. Our key assumption here is that the weekly patterns visits are a reasonable representation of patterns visits on election day. If we wanted to correct for this assumption, we could look at the weekly expected traffic from the weeks prior or the weeks after and correct for that. Okay, we'll go through the methods and then I'll move over to the notebook and we'll actually do a live demo of the code to see what this looks like. So first we need to read in the data, and then we'll need to join the voting data with SafeGraph's patterns data. There's 3 steps to that. We'll need to join the results and the polling locations together first on precinct column, and then we'll have to add the Placekey column to that voting data. And then we'll be able to join patterns and voting data on Placekey. Then we'll explode by visitor home CBG, that JSON column that we looked at. And then we'll normalize SafeGraph visit counts by the underlying patterns panel. SafeGraph's underlying panel is only a sample of the entire US population. So we want to try to scale that so that we actually have an estimate of the real number of people visiting these POIs. Then we'll compute the vote portions by census block group and polling location. And we'll aggregate those CBG votes in so that we can have a calculated estimate of votes by candidate for each CBG. And then finally, we'll map the estimates so we have an idea of what we created. So this time I'm going to move over to the Google Colab notebook. Again, this is what we're looking at. This is the standard way of doing things now, and this is the level of resolution that we can get to. The first step here is to install the necessary packages in your Google Colab environment. Google Colabs are hosted on the cloud, so it's not putting anything on your own computer, it's actually putting it on the Google machine. And then once you have that, you can install all the needed packages into the Google Colab environment. As I go through this notebook, I'm going to focus on the code block level. So I'm not going to go through things line by line. I'll go through things by code block and I'll tell you what each code block is doing. If there's anything that you'd like to see in more detail, feel free to ask them in the Q&A portion. Okay, so I posted on my GitHub, and in this code block, I'm just allowing for easily reading in the data. I have all the links listed over here, and just a reference so that we can get to the necessary data easily. Now, if you don't have a Placekey API key yet, that's okay. For the purposes of this demo, I've put all of that data on GitHub so that you can just read it in. I'm going to read in my own Placekey API key so that I can access the API and append place keys by using that tool and show that to you. Okay, we've done some setup, so now we're ready to actually read in the data. First, we'll read in the SafeGraph weekly patterns. This data set has been trimmed just to Forsyth County and Cobb County in Georgia, the state of Georgia in the US. And you can see here we have our Placekey column, we have a location name, a category, street address, city, region. And then if we scroll over a little bit, you can see things like the raw visitor counts, visits by day, visitor home CBGs. Also interesting is the distance from home and median dwell, which we won't really use in this demo, but it's good to know that that data is there. Next, we'll read in our results data set. Again, these are the Forsyth County results, and they're organized by precinct. So precinct 1, named Big Creek, has 11,222 registered voters. It saw 535 election day votes. I linked to the location that this data came from, and there are some documentation to figure out which of these columns correspond with which, and I have that built into the code later. Next, we'll read in our location. again, you'll notice that the results data set doesn't have any address columns. So we have to read in the locations from a different source, and then we can join on the precinct column. And that's what we'll do in the next code block. And we'll store that in this locations results variable. So for example, you see in this first entry, we have the precinct name, location, address, city, zip, precinct name again, and all of our vote information from the results data frame. We're going to simplify these columns a bit to only get to the columns that we're interested in, and we'll label them so that they're a little more user-friendly. Okay, so now we have our in-person Trump, Biden, and Jorgensen vote totals. Our next step is to add a place key column to this data frame so that we can merge it with the patterns data. To do that is pretty easy, actually. We just need to format the data for the API. To do that, we need a query ID column, street address, city, region, postal code, and location name. We have all those data fields in the above data frame. We just need to rename them for the API, which is done in this code block. And then finally, we need to put the data into a JSON format, which again is to conform to the Placekey API. Here's an example of what the first entry in our data frame looks like from above in JSON format. Now we're ready to actually request the place keys from the Placekey API. It's a really easy process that has a built-in tool, built-in package with Python to do. And just like that, we have our place keys. So for our first record with a query ID of 0, we see that our place key has 15 characters. But you'll notice that the last two records that we returned and showed in this sample here only have 12 characters. And that gets back to what I was talking about earlier about Placekey with the address portion, the POI portion, and the H3 hexagon portion. If the Placekey API can't nail down exactly which point of interest you're looking for, it'll still give you a place key that's just based on the address. So what we need to do is trim the rest of these place keys down to just their address so that we're working with apples to apples here. Now, if you don't have a Placekey API key, you can remove the comments on these two lines, and you can run this code so that your place keys get stored into df place keys here. So here we're merging the place keys back with our original data set, and we trimmed all the place keys down to just 12 characters here. Now we're ready to merge them with patterns. So we'll print the patterns data frame once again so that we can see what we're looking to do. We have our precinct results up here, and we have a place key that corresponds with a place key, hopefully, in our patterns data. But once again, our patterns place keys are 15 characters, while our other place keys for the voting data is just 12. So we're going to have to trim these place keys down to just the address portions as well. And then once we do that, we can merge them together. All that's done in this code block. And now we can see the precinct, registered voters, and the results, the place key, along with our foot traffic data from SafeGraph, the raw visitor counts, the visits by day, and most importantly, the visitor home CBGs. So this visitor home CBGs data column is in JSON format, which again means that each key is a census block group, and each value is the raw visitor total from that census block group to the given point of interest. What we need to do is explode this column so that each entry in each JSON object is given its own column. And that's what we do in the next code block. Now that step might have been a little bit confusing, so I'll take a moment to show what the difference is here. I've printed out, well, in this above data frame, we have one row for the first precinct, for precinct number 1. In the next data frame, we have a bunch of rows for precinct number 1. And each row corresponds to a home CBG. So each CBG here is a unique pair with the precinct over here. And this visitors equals 7 means that this census block group had 7 visitors to precinct 1 during election week. Okay, the next step is to scale these counts because, again, SafeGraphs only has a sample of the entire United States population. So we want to try to get those estimates closer to what we might think of the actual numbers. There's a couple steps in doing that. First, we want to add this census block group's population, which is available through the census. We can just read in that data and append it. So this census block group has a population of 2,522 people. Our next step in scaling is to add this home panel summary, which is provided by SafeGraph. First, we'll read in the data. So we see for the date range from November 2nd to November 9th, which was election week, there's an entry for each census block group in the United States, including the number of devices residing. So these are the number of devices in SafeGraph's panel that live or have their home in the given census block group. So what we want to do with that data is take the number of devices residing and scale it with the census block group's population. So for example, in this census block group, we saw 7 visitors. The census block group had a population of 2,522 people, and SafeGraph's panel that week saw 190 devices that had their home in that census block group. So our scaling factor is 2,522 divided by 190, which gives us about 13.3. So now when we multiply the number of visitors we saw by 13.3 to get our scaled number of visitors. Additionally, I have a column here for the total number of visitors to that point of interest scaled. So the visitors scaled corresponds to the census block group at this point of interest, and the POI visitors scaled corresponds to the total number of visitors to this point of interest. And we use that to disseminate the vote portions accordingly. So the portions that we're making here estimate the number of votes at each polling location from each census block group. SafeGraph's data says that about 92 or 93 visitors were at this point of interest from this census block. In total, 945 visitors were at this point of interest. That means that about 9.8% of the total visitors to this point of interest were from the given census block group. So we want to take this portion, about 9.8%, and multiply it by the total votes for each candidate. And that's what we get here. So if we look up here, here we are. So if we look up here, 9.8% of 535 gives us about 52. 9.8% of 252 gives us about 24 or 25. And 9.8% of 19 gives us just under 2. So those are our vote estimates for this census block group at this point of interest. Now, again, we know that each census block group may have people that voted at different points of interest. Some people voted at one polling place and some people may have voted at another polling place. So we need to sum all of these vote totals by the census block group. Now we see for this census block group, they had voters, or we're estimating that they had voters at these 5 precincts. We summed total votes from each of those 5 precincts according to the portion of votes that were from this census block group, and these are the totals that we got. So for a census block group given here, we're estimating that about 139 of them voted for Trump in person, about 44 of them voted for Biden, and about 7 of them voted for Jorgensen. Okay, now we're ready to actually get the estimates. So it's nice to have these solid numbers, but in order to visualize what we actually just created, we want to estimate the portion that went to each candidate. So on 138, votes for Trump represent about 73% of the vote totals coming from this census block group. Additionally, 44 votes for Joe Biden represent about 23% of the votes from this census block group. Now we'll sort these estimates to give us a little bit better of an idea of what's going on here. We can see that the census block group with the most visitors also actually had the highest population. And additionally, the census block group with the least amount of visitors scaled had the lowest population. And you can see the corresponding estimates for the political affiliation, the candidates of choice for in-person voting for each census block group. Now we want to visualize this because the numbers aren't really helpful just by themselves right now. In order to do that, we can append the census block group geometries. So first we'll read in this file, and then we'll append it to our estimates here. And the geometries for a census block group are just given in a shapefile. It's basically a number, a list of coordinates, latitude and longitude, that give you the outline of the census block group. So it's really helpful to have those appended on when we're actually trying to visualize what they look like on a map. Up until this point, we've just been working with Forsyth County. And here we have a code block to automate all of that with Cobb County, which is just northeast of Forsyth, southwest of Forsyth County. So I ran through all the code. These are the exact same steps that we took with Forsyth County. And here is our resulting data frame, our estimates data frame with the geometries for Cobb County. We'll combine the data frames so that we can map them together. And then finally, we'll just define a mapping function that really isn't the focus of the notebook, but it helps us to see what's going on here. And we can map our estimates. Okay, so I set the map coordinates to be just north of Atlanta there. And here are the estimates that we just created, starting with foot traffic data and results and locations. And here we have something that's actually pretty insightful. If we zoom in, you can start to see the scale that this is on. You see the streets and the neighborhoods that are all encompassed in a census block group. Remember, census block group corresponds to between 600 and 3,000 people. And you can see highlight each how many were Republican and how many were Libertarian votes. So this is Cobb County here. And as you get closer to Atlanta, more of the census block groups are leaning towards Democratic. And as you get farther away, more of them are Republican. For Forsyth County, pretty much all of the estimates are Republican. So again, just to recap where we started and where we're at now, the current standard way of doing things looks at the county level, which, as we see in Cobb County, ignores some pretty important variations within the county. So if you're looking to do some research in Cobb County, right now there's a good chance that you're just assuming that everyone is slightly Democrat leaning. But we can break it down quite a bit at higher resolution than that. I also have a map for Minnesota to show you what this might look like on an entire state scale. Now, some of the counties and census block groups in Minnesota are pretty sparsely populated, but we'll zoom in on the Minneapolis-St. Paul area. And you can really start to see some interesting data here. As you get closer into Minneapolis and St. Paul, it's pretty Democrat leaning. But as you get farther out into the rural areas of Minnesota, there's some more Republican leading census block groups. Down in the southeast portion of the state and Rochester, seems like most of these census block groups are fairly Democrat leaning, but there are a couple that are Republican leaning in there as well. Okay, let's go back to the slides and we'll talk really quickly about some of the limits and considerations. First, ethics. Is it ethical to actually calculate these estimates at such a high resolution, and are there any privacy considerations? Well, the CBG level estimates are the standard used by the US Census Bureau to collect and share demographic data. Additionally, these estimates are based on anonymized samples, meaning no individual's political affiliation could be identified. Even if a census block group were estimated as 100% affiliated with one party, the estimates are still based on samples, so there's room for error there. Next, sampling bias. Is SafeGraph patterns representative of the United States population in every geography? Without normalization, SafeGraph's underlying panel from 2018 underrepresented older and non-white voters. However, we have reason to believe that these estimates are still valuable despite this bias. First, the SafeGraph underlying panel has grown significantly from November 2018 to November of 2020. And second, we normalized the patterns data in an attempt to correct for some of this bias. Despite those improvements, it's important to remember that bias will always exist at some level in the data and results. Additionally, the bias might not be consistent across geographies, so that's another thing to keep in mind. Foot traffic only, adjusting for mail-in ballots. How can we adjust our estimates to take into account mail-in ballots? To do this at the CBG or precinct level, we must understand the underlying results data. Do absentee votes count for a precinct do absentee votes for a precinct correspond to just the census block groups that vote at that precinct? And if so, then we can distribute the absentee votes to each precinct's census block groups. We need to weight by population though. But if we don't know enough about the underlying results data, we can still correct at the county level. We can assume that each mail-in ballot is only valid in the same county as the voter resides, and then we can distribute each county's absentee votes to each census block group in the county, again considering the weighting by population. And missing estimates. How do we handle missing estimates? On those maps, we had quite a few census block groups that we just didn't make estimates for. Now, depending on the needs of the research, there are a few ways you might handle this. First, you could omit the missing census block groups, just don't even include them in your research at all. Second, you could use median or mean imputation, which would be assigning the county-wide median to the missing census block groups. Third, you could use some sort of nearest neighbors imputation. And fourth, you could use a nearest precinct weighted average. Just look at the distance from the census block group to the nearest couple of precincts and take an average. In conclusion, we've demonstrated the foundation to building a census block group resolution political affiliation census. At scale, this task would be nearly impossible without Placekey, allowing the address or POI-based joins. The resulting political affiliation estimates have value for researchers, marketers, political campaigns, and more. Thank you for listening to me. And if you'd like to learn more, I would encourage you to check out the Placekey website or join the Placekey community. It's a free Slack community for geospatial data enthusiasts. You can receive support there, share your work, or even just connect with others in the GIS community. Really appreciate you taking the time today. And I'm happy to answer any questions that you might have.
Thank you, Ryan, for the presentation. And you got a shout out for having a really well written out notebook with great comments and all of that. So thank you for that. Yeah, if anybody has any questions, feel free to post in the chat. Now is a great time to ask Ryan while he is online. Yep, thanks for sharing the link to the Placekey community. So I do have a question. I see CBG is Census Block Group, and I saw POI, which is it a place of interest? Is that what POI means?
Point of interest, place of interest, probably the same thing.
Okay, all right, great. So I guess the other question that I have for you is, what are other applications where people are using a Placekey?
Yeah, there was actually a recent project specifically on the PPP loans. So in the first COVID relief package, there was quite a bit of money for small businesses, and it was difficult for the local governments to track how much of the money is going to each of the businesses in their community, because they have these records at the federal level that say how much money is going to each business, and it's by address. And then they have their records at their local level by address as well, but the addresses aren't always going to be standardized the same way. So there was actually a pretty big case study that took place Johns Creek in Georgia as well, just coincidentally, that looked at that and allowed the local government to better assess where the money was going so that their businesses were getting what they needed.
Oh, great. So another question I have is Placekey fairly new? Because I'm wondering, what did people use before Placekey?
Yes, fairly new is accurate. I believe it actually launched officially in October of 2020. So it has not been around for very long. And before Placekey, it really depended on your use case. There are a number of address standardization services or address matching. And if you want to do them at the POI level, unfortunately, most of them are not open. They're not going to be free at scale. They might have really strict rate limits. So I think the USPS, the United States Postal Service, has an address standardization service. So Placekey is really like the next step above that, and then it allows you to do it for free. Really, is probably the biggest thing about it, is that it's free no matter what scale you're working on.
So there's a question which was, can you use this for COVID data?
I'm sorry, could you repeat that?
Can you use Placekey for COVID data?
Oh, certainly, yeah. I mean, it's going to depend on your use case. So Placekey is good for any time that you have two data sets that are POI or address based and you need to join them together. So if you're looking at maybe something like hospital records or infection rates at various points of interest, I think Placekey is going to come in handy there. Especially one that comes to mind is if you're looking at a hospital's specific capacity and maybe what their maximum capacity is or how full they are relative to their capacity. And maybe you want to join that based on foot traffic data to the hospital or how much federal money, federal assistance the hospital has gotten. Really any point of interest data for that hospital, or all hospitals across the US or across an entire state or region. Placekey is going to come in handy there.
So how about, is this international data? Like, does this Placekey work all over the world?
It is not yet, is the answer. Right now, the United States is completely covered. and it's growing every day. And my understanding is that there are big plans for international expansion, hopefully to the point where every place in the United States does have, or in the world, excuse me, does have a Placekey. It is a tool that relies on the cooperation of all of the GIS community. The idea is that the entire GIS community can really grow from this together. And I see Jack in the comments is saying that US is available by point of interest. Canada has a beta version, and it looks like the United Kingdom will have one launching potentially in April. So that's exciting to get into Europe as well.
So I have another question, and there's a siren just now. The question I have is, so you did the presentation using Colab and Python. My question is, for people who use other languages such as R or Julia or Java or JavaScript, what's the support for other languages?
Sure. There's a number of different integrations and languages that Placekey is compatible with. The great thing about the API is that it is just a standalone API. You don't need a package to work with it. I use the Python package because it makes things a little bit easier for me. But even if you had a language that wasn't given a package or doesn't have a Placekey package yet, you would still be able to use the API with that. That being said, most of the programming languages do, and there are actually a number of no-code solutions as well, including like Google Sheets, Microsoft Excel, Carto, QGIS, if you're familiar with some of the GIS tools like that. And then like R has its own package. So there's a lot of tutorials and starting resources to help you get started with the API. And the no-code solutions are really great too, because this is a tool that's valuable for local governments that maybe don't have any data people or even computer programmers at all. And so they can just use this integration in their Microsoft Excel or Google Sheets to add Placekeys to their data and then join it if they need to.
And I actually have another question too. I said earlier, for people who joined late, I was just working on a project over the weekend where I needed latitude and longitude for like 250 cities of PyLadies chapters around the world. And so the question that I have now is, I can turn my camera back on, is what is, I see that, you know, you have US, Canada's in beta, UK is tentative, Netherlands is coming along. What is your path for which countries? How do you choose what countries you move on to next to add to the database, I guess?
Yeah, I don't think I can answer that, unfortunately. I'm not sure. I think it's demand driven. If there are a number of researchers that are looking to solve a problem in a certain country, then I think the Placekey directors, or the people running Placekey, will look at that and take that into account as their next direction.
Ah, great. If anybody else has any questions, please feel free to post. Now is a great time to ask. Okay. And so I guess I do have one more question. I noticed the Placekey code is, I don't know, is it 9 digits long or 9 characters long? Is that right? Did I get that?
So there's 9 characters in the where portion of it, and that'll tell you the hexagon, where on the Earth that hexagon is located. Mm-hmm. And then there's an additional up to 6 characters for the address component and the POI component.
Okay, great. And this is like another question. I was thinking about the globe of the Earth. What about water? Like, is there a plan to have a Placekey based on geographical location? Like if somebody has a boat out there, or what's?
Yeah, so that's a good question. And the where portion of the place key that corresponds with that hexagon, that part of Placekey is actually, it covers the entire the entire world. So anywhere in the world that you have a point is actually covered by one of these hexagons. Now, if you're out in the middle of ocean, you might not have a point of interest there. Maybe you will, maybe you won't. I'm not sure if Placekey is going to get that coverage in the near future, but that's definitely possible because of where those hexagons cover, which is the entire globe.
Okay. And then another question I have is any portion of the Placekey code connected to latitude and longitude? Like, is there any connection there at all?
So that's a great question. There's not a intuitive connection where you can look at a code and just, calculate what the latitude and longitude is. But there are services that you can connect to where if you have that hexagon portion of the code, the where, you send that into whether with a library in Python, and the library will give you back the latitude, longitude coordinates. I believe you can get the centroid of the hexagon, or you could get the points that make the hexagon up, the outline.
Oh, I was on mute. I think I know what the sound is. Sometimes, like if I talk, if you go on mute, it's easier. But yeah, sometimes that's I feel like that's the whatever that sound quality is. That's great. I'm really looking forward to seeing seeing like how this goes, because I think it's really valuable. Yeah, if you thank you so much for joining. If there's anything that I know that Jack shared some links to Placekey, the Placekey community, and we have your GitHub as well, mapping H3 to real world. Okay, that's great. I can take these links out afterwards, and we have like a info sheet for each webinar, so I can save these links to that info sheet so people have it for reference as well. Thank you so much for your presentation. It was great. Yeah, I mean, if you have any closing words, feel free to say them now.
Well, I'd just like to say thank you for having me again. It was an honor to give the presentation to this group. And if you have any questions, feel free to, I guess, message me on the community, shoot me an email, whatever you want. I encourage you to play around with the notebook as much as you see fit. That data is there. You could also try to calculate things like the median dwell time for a census block group to look at things like voter suppression, and maybe some census block groups don't have as much access to their polling places as others. There's a lot that can be done. There's a lot that could be improved upon. So this was really just a foundation. And if you want to get your hands dirty with Placekey and with some pretty cool data, I'd encourage you to continue looking at the notebook and go through it yourself. So thank you.
Thanks, Ryan.